Hi, I'm Stephane Houel. I'm a senior scientist at Waters Corporation. Today I'm going to talk about the characterization and comparison of O-Glycosylation between the Innovator and Biosimilar of Etanercept. The goal of this work was to assign on this specific protein the O-Glycosylation site, the first step. The second step was to compare the distribution between the Innovator and the Biosimilar. Why did we choose Etanercept? Etanercept is a blockbuster drug, but it's also a great challenge in the analytical world because of all of those O-Glycosylation sites. For the sample preparation, we changed the workflow a little bit. The first step is a common one. We remove the ending glycan. But for the second step, for the sialic acid, we know Etanercept is expressed in CHO cell. So you will have a core one with 1 or 2 sialic acid. We use neuraminidase to remove the sialic acid. So now we'll have the protein with just the core one attached. And the last step would be trypsinization. And then we'll have a mixture of peptide with or without the O-glycan. And with the O-glycan, we'll just have the core one structure. So on figure 3, you can see we run the same sample 3 times. We have 3 replicates. And after that, we process the data with biopharma links. In the table 1, you have the result of this triplicate analysis. To qualify a peptide, we needed to have at least 5 BNY ions, and on the primate mass, an error plus or minus 5 ppm. So what you can see on table 1, you have a minimum number of 13 sites that are occupied. And all of those sites are on 5 different peptides. T1, it's a tripeptide, so we'll call that T1, T13, T14, T15, and T17. And you can see that the peptide T17 has up to 7 O-glycosylation sites. And you also have 2 glycoforms with 6 sites on it. And the retention time are 45.4 and 46.5. So now that we identified all of those peptides, the goal was to map the sites. But unfortunately, when you do CID experiment, you cannot have the identification because you have mostly neutral loss. So now we go to the next step. We run a targeted ETD method. So we kept all of the LC the same, but now we're using a targeted ETD method. So on figure 5, I show you an example of the raw data, and after the convolution with MaxN3 is the example of the T14 with 2 glycosides on it. And you can see that we have a very, very good coverage of this peptide, and we can identify without any trouble the sites that are occupied. So in that case, it was Z2 and Z3 are occupied with the core one structure. So if you look at the mass of Z2, it's TR plus the core one, which is 365. And for Z3, it's STR plus 2 times 365. So it was very, very easy to identify the sites. So now you say, OK, that's fine for when you have 2 glycosides. But what about when you have 7? So this is the example with 7. And obviously, you don't have a complete coverage, but you have enough fragment that you can assign all of those sites on it. You have 11 serine and threonine, so you have 11 potential sites. But at the end, you are able to assign all of those sites that are occupied. Now I show you also the example between 6 core 1 on the same T15 peptide that have these 2 peptides have different retention time. And you can see which one occupied and not occupied. So now that we have all of those sites that are assigned, we can compare the Innovator versus the Biosimilar. And this is what you have on figure 6. So on figure 6, on the top of the figure, you have the Innovator. The second one, you have the Biosimilar. And the last part at the bottom of the figure, it's the normalized intensity that I compare between the glycopeptide with 7 O-core, 6 O-core that elutes at 45.4 minutes, and the 6 O-core that elutes at 46.5 minutes. And you can see that between the Biosimilar and the Innovator, the 7 O-core, the normalized response is more or less the same, that you can conclude that between the Biosimilar and the Innovator, you have the same amount of that glycopeptide. But now if you compare the 6 O-core that elutes at different retention time, you can see the distribution is very different. So by using this workflow, you can start to assess the biosimilarity between an innovator and a biosimilar. On table 2, just below the conclusion, I just give you all of the sites that were identified, and we can do the same type of example, compare the intensity between the innovator and the biosimilar. So in conclusion, we design a workflow that helps us to target some glycopeptide and to analyze the O-link glycopeptide that are usually very difficult to do. And then we use a SYNAPG2S with ETD capability, and we successfully accomplish our goal. Thank you very much.